Students, in continuation of mechanical properties of solid, let's start with Young's modulus, right? Give hearing. It's a very theoretical chapter, not that much difficult, right? Young's modulus. So Young's modulus, students, right? It is defined as the ratio of. Keep on writing with me. Later on, I will also update the note. It is defined as. Just right. It is defined as the ratio of the. It is defined as the ratio of the normal stress to the longitudinal strain. To the longitudinal strain, right? That means, student, for example, let it's the roof and a body is hanging, let this the body is hanging. This length is let L, करेक्ट है ना? सो अगर इस पॉइंट से देखें तो ये थोड़ा किसी भी तरह एलोंगेट हो गया, मतलब इसके बाद ये इतना ही एलोंगेट हुआ, लेंथ पे कुछ बदलाव आया, लेट दैट इज डेल्टा एल, स्मॉल चेंज इन लेंथ, राइट? So Young's modulus y, that is most probably symbolized as y, right? So right, Young's modulus y is equal to, you know, longitudinal stress by longitudinal strain, right? Longitudinal stress by longitudinal strain. That means y is equal to stress matlab force by area F by A divided by strain matlab L delta L by L. That is L going to of FL by A delta L. This can be written as a longitudinal Young's modulus, right? So what are the questions that used to come on this chapter? Let's discuss one by one each concept, right? Elongation of rod under its own weight. Give heading. Like question जो मैं उसकी सिनॉप्सिस बता रहा हूँ, आपको असाइनमेंट में क्वेश्चंस मिलेगा, एनसीईआरटी में भी देखना, एक्सरसाइज में भी देखना. Elongation of rod under its own weight. Elongation of rod under its own weight. Elongation of rod under its own weight. Student, what does it say, right? Let there is a rod having weight W and area of cross section A and length L, right? So let's write it. Let rod having self weight W, area of cross section A and length L. ठीक है, मतलब इस तरह से है. लेट ये एक सपोर्ट है और हमने ये एक रॉड ले लिए, राइट? लेट दिस इज अ रॉड, दिस इज अ रॉड having length L. ठीक है. So student, consider on the element at a distance x from the bottom, मतलब नीचे से एक एलिमेंट हम कंसीडर करते हैं जो कि x की दूरी पर है और जिसकी वाइड dx है ना? राइट? So just write here, consider an element at a distance x from bottom, then tensor is equal to how much, student? What will be force in that part? So total weight W by total length L into weight of the small part. So that will be the tension. Yes or no? Total weight is W of this total rod. Length is L. Then per unit length पे कितना weight divide हुआ है? W by L. और हमें कितनी weight लेना है कि x distance की? तो elongation कितना होगा? Let's find the elongation, right? elongation in dx element, elongation in dx element, that is equal to t into dx. Students, see here, force, how much force, what is the length, right, into area, right here. So elongation dx in the element is t into dx by a into y, right here, correct. So total elongation we want to find here, we want to find the total elongation. That means you have to integrate, we want to find the total elongation. So to find the total elongation, what you have to do? So that is s is equal to, you have to, the dx you have to vary, t dx by ay, length is 0 to L. So that is equal to how much? W. T is how much? It's here. W by L into X, right? So you can write here W by L into X into dy by Young's modulus, right? The length is 0 to L. Now here you see T by W, T W by L into X. So if I'll solve that one, then I will get, that is weight W into total.
To dx.
Student, this is the total elongation, and you can directly do by considering the total weight as center of mass. Directly you can take, because it's a rod, the total weight is concentrated at the center, so the total weight is concentrated at distance L by 2, right? Let's make compare this rod concept with a spring, right? Let's see the rod concept with a spring. That means analogy of rod edge spring, analogy of rod edge spring. That means, friend, what is Young's modulus? You got Young's modulus y is equal to f into length L by area into delta L. Yes or no? So from here only you can find force is equal to how much? No, sir, A into Young's modulus by L into delta L. This is the force, na? Yes or no?
Yes.
And for a
Yes.
for a particular case, that the rod is fixed, so Young's modulus is fixed, length is fixed. So that means here A Young's modulus by L that we got on the top, that constant, it's a constant for a particular case, right? And it depends on type of the material, right? Depends on type of material and also geometry of the rod. What is the length and what is the Young's modulus, what is the area, on that also it depends, na? So that is known as geometry of rod. So indirectly I can write F is equal to K delta L, na? Can we write or not? ऐसे भी स्प्रिंग पे हम लिखते हैं ना, A proportional to X and F is equal to minus KX. Do you remember about spring? है कि नहीं? और
Yes.
ये जो K हमने लिए हैं, K किसके बदले में लिए हैं ना सर? A into Young's modulus by L, right? So ये जो हमने लिए constant, this is equivalent spring constant. We can also say, we can say is it equivalent spring constant. Is that clear to all? This is
Yes.
equivalent spring constant, right? If this is equivalent spring constant, then see, if I will compare the total length which with spring constant K, that means let's draw a diagram, then you can understand, right? Friend, this was a rod, right? This was a rod, correct? Yes or no? Let in the rod there was a length L1. This rod one having a length L1 and area A1, and it is having a material Young's modulus Y1, correct? Another rod is there below to that, which is having length how much? L2. Area of cross section how much? Y2, A2, and Young's modulus for this material is Y2. Students getting na? So before to that,
Yes.
I am giving one example. Then we can see what is the series and combination of resistances. So in normal rod, what we found out, what is the spring constant? If a rod is there, right? The rod is having length L. Normal rod is having length L, area A, and Young's modulus Y, right? You gave some force and it's elongated. Let that elongation is delta L, right? And the force that we're applying, that is F. So here, this part can be considered as a spring, na students? This part can be considered as a spring length, right? And the spring is elongating by a length how much? Delta L. We have also taken as delta L, right? And the force is F here, and we have taken a spring constant K, na? And what is the K value? Na, sir, K is equal to area into Young's modulus by length. Is that clear or not? Getting, na, students?
Yes, sir.
So that means this diagram we can compare this one with a spring. That means here one spring is connected. This is one spring for the first rod. This is another spring, right? Here the spring constant is K1. Here the spring constant is K2. And what is that K1? No, sir, A1, L1. No, sorry, not L1. That is Young's modulus 1, right? Of the first material, A1 Y1 by L1. So similarly, K2 will be how much? A2 Y2 L2,
A2, Y2, L2.
right? And we combined these two, and we got the equivalent spring. That is a equivalent spring, and K equivalent is equal to how much? You add those K1 plus K2, yes or no, and you compare, and you will get that is equal to spring constant, you know. So in work energy power I taught you, K1 into K2 by K1 plus K2, yes or no? You remember?
Yes, sir.
So this is the thing. So this concept will be also applied in some of the question. So this is the combination of rods in series. Let's take an example where the combination of rods will be parallel, right? Let's take an example where the combination of the rods will be parallel. Yes or no? This is series. So let's take another combination of rod. Yes or no? Replaced by spring system. Because you will not get directly spring concept, but you have to keep in mind the spring concept so that you can take the approach for the questions. This is one rod. Take this is one rod, right? Oh no. Let's take this is a small rod, correct? This is another rod. Let this first rod is having A1, Young's modulus Y1, and length is L1. Getting the students? Second rod, let A2, Y2, and L2, right? Third rod, A3, Y3, and L3, right? So these are connected, and I'm giving a force F. So we can combine the system into a spring balance, na? We can into a spring system. That means one spring connected like this, another spring connected like this, and both the springs are connected to one spring. Yes or no? This is the scenario, na, for the case, and you're applying a force here, correct? And what is K1 here? That's a simple thing, A1 Y1 by L1. What is K2 here, students? That's the A2 Y2 by L2. What is K3 here? No, sir, A3 Y3 by L3. Correct? Getting or not, students?
Yes.
And by combining these two series system, you know the formula for K1 into K2 by K1 plus K2. You can get the series connection, and both are connected parallel. Then you can deal with springs in connected in series and springs connected in parallel. Understood all? Students understood, na?
Yes, sir.
Okay. Then next, let's this was the case. This was the case, right? Next, go to electric potential energy, elastic potential energy stored in a stressed wire or in a rod, right? Next, another bit of application of that, right? Elastic potential energy stored in a stressed wire. Elastic potential energy stored in a stretch wire or in a rod. Let's see what is elastic potential energy, correct? जैसे स्प्रिंग में होता है आपके x square energy stored, right? Let's see here only, students. For a wire, for a wire, what you knew that for a wire, Young's modulus is equal to how much, you know? Now F into L by area into delta L. Yes or no? And that F is equal to how much, you know? No, sir, A into Young's modulus, the L into delta L. Up to this, you all clear how this formula came? From the very starting, Young's modulus, right? Young's modulus, see here, pressure, well, stress by strain. So L went off, so FL by A delta L. So that thing only I'm writing here. by taking F to one side, that is AY by L into delta L. Getting or not all?
Yes.
How I wrote
Yes,
this?
sir.
Getting? Yes. See. Mukesh, are you getting or not? See here. So students, the where behaves like a spring, right? And in which the spring constant is how much? The A Young's modulus by L. And you know, from here you can see the spring constant is inversely proportional to length, na? Yes or no? For a particular where if area is constant, Y is constant, Young's modulus is constant, then K is inversely proportional to L or not?
Yes, sir.
तो अगर हमने एक वायर को स्ट्रेच किए, मैंने एक वायर को स्ट्रेच किया बाय फोर्स F and delta L is the extension produced, then work done is equal to how much, students? W is equal to force into displacement ना? और मैंने कितना फोर्स दिया? मैंने F फोर्स दिए थे और डिस्प्लेसमेंट कितना हुआ? डेल्टा L, जैसे हमने अभी किए. देखो मैं नहीं तो फिर और एक बार यहाँ पर ड्रा कर देता हूँ. दिस वाज ए वायर, राइट? हमने इसको थोड़ा सा एक्सटेंड करवाया है ना, जिसका A है एरिया, Y यंग्स मॉडुलस, दिस इज L, और यहाँ पर ये F है and this is X, correct? So this is the displacement X and this is the force F. ये जो थोड़ा डिस्प्लेसमेंट में दिखा रहा हूँ, ये जो X डिस्प्लेस हुआ, राइट? तो इसी केस पे वर्क डन कितना हुआ? कितना फोर्स मैंने अप्लाई किया इनटू कितना डिस्प्लेस हुआ, दैट इज DL, करेक्ट और नॉट?
Yes, sir.
And work done by restoring force, work done by restoring force. So देखो F is equal to kx and you already know energy stored in a spring is equal to half kx square ना. बट रिस्टोरिंग फोर्स कितना काम करता है स्टूडेंट्स? देखो जब कोई भी स्प्रिंग को हम स्ट्रेच, यहाँ पर जितने फोर्स पे स्ट्रेच करते हैं ऊपर बैकवर्ड डायरेक्शन में रिस्टोरिंग फोर्स एक्ट करता है ना? यस सर, नो?
Yes, sir.
तो एक्चुअल में मेन फोर्स कितना लगेगा? आधा हो जाएगा, राइट? सो नंबर 2 पे लिखो, अगर कहीं पे पूछा कि व्हाट इज द वर्क डन बाय रिस्टोरिंग फोर्स, राइट? वर्क डन बाय रिस्टोरिंग फोर्स that is equal to half into F delta L, right? नेक्स्ट स्टूडेंट, जितना वर्क होगा वो मतलब उतना ही हीट प्रोड्यूस होगा ना? तो व्हाट विल बी हीट प्रोड्यूस्ड? सेम. सो अगर सेम पूछा तो हीट प्रोड्यूस कितना होगा? सिंपल, हाफ इनटू कितना फोर्स दिया हुआ है इनटू कितना एक्सपांड हो रहा है डेल्टा एल. नेक्स्ट, अगर कहीं पे आपको क्वेश्चन में पूछा वो इलास्टिक पोटेंशियल एनर्जी, दैट इज सेम ओनली, राइट? इलास्टिक पोटेंशियल energy U. So that is how much? That is equal to half into F into delta L, the same thing. बट कभी कभी क्या करता है स्टूडेंट, एनर्जी डेंसिटी पूछता है, मतलब एनर्जी पर वॉल्यूम, एनर्जी पर वॉल्यूम. यही से एक इंपॉर्टेंट पार्ट है ये इस पूरा लेक्चर की, एनर्जी डेंसिटी कैसे निकालते हैं, राइट? एनर्जी वाई, एनर्जी डेंसिटी, हाउ टू फाइंड एनर्जी डेंसिटी, दैट इज यू लिखा जाता है. तो दैट इज स्टूडेंट्स इज इक्वल टू पर वॉल्यूम, मतलब हाफ F इंटू डेल्टा एल था डिवाइडेड बाय वॉल्यूम, करेक्ट है ना? सो दैट इज इक्वल टू हाफ इंटू F इंटू डेल्टा एल डिवाइडेड बाय AL, राइट? तो देखो यहाँ पर थोड़ा हाफ इंटू, ये कितना हो गया? स्ट्रेस हो गया ना, और ये कितना हो गया? स्ट्रेन हो गया, करेक्ट? सो दैट इज इक्वल टू हाफ इंटू स्ट्रेस का स्क्वायर बाय यंग्स मॉडुलस, बिकॉज स्ट्रेस बाय स्ट्रेन इज यंग्स मॉडुलस ना, रिप्लेस कर सकते हैं इसको. So that is equal to half into y into strain square. So that is energy density. Got an idea how to find energy density? अगर सिर्फ आपको
Yes.
यंग्स मॉडुलस दिया गया होगा और स्ट्रेन दिया गया होगा तो तभी भी आप निकाल सकते हो ना एनर्जी डेंसिटी, है कि नहीं? ठीक है स्टूडेंट्स, अंडरस्टूड ना दिस पार्ट?
Yes, sir.
So by remembering this much, you can now go to the questions of NCERT and solve the SLOD examples, right? Then we'll next class we'll start with Poisson's ratio. ठीक है? Another one or two class we'll take tomorrow. By taking one or two class in the morning and the evening time, we'll complete this part. Okay.
Yes.
So this was for today.